Hello, future engineers. This is Madan Mohan. And remember, engineering is not just a subject, it's a passion, it's a mindset, it's a lifestyle. Today, in this video, we are seeing about Ampere's circuital law described by Andre Marie Ampere. Electric current does not just flow silently through a conductor, it creates a magnetic field around it. The moment charges move, magnetism is born. The law that mathematically connects electric current to the magnetic field surrounding it is known as Ampere's circuital law. So coming to the statement of this Ampere's circuital law, the line integral of magnetic field intensity around a closed path is equal to the total current enclosed by that path. So if we say mathematically, closed integral of h bar dot dl is equal to I enclosed. So here h represents the magnetic field intensity. I enclosed is current enclosed by the closed path. If we represent J as a current density, can be expressed as I enclosed is equal to surface integral of J bar dot ds. So closed integral of h bar dot dl is equal to surface integral of J bar dot ds. So by using Stokes theorem, and if we can apply Stokes theorem to left hand side of the equation, the closed integral of h bar dot dl is equal to surface integral of del cross h ds. If we can equate the integrands on the both sides, it becomes del cross h is equal to j bar. So the important condition is that it is valid only for steady currents, that is time invariant, and it is not valid for time varying electrical fields. That's all about Ampere circuit in very simple way. Thank you. Bye.